The metallic clang of tank treads echoed through the frost-covered forests of Belgium in December 1944. German panzer crews, ensconced within their massive Tiger tanks, had grown accustomed to a particular sound on the battlefield, a sound that had become almost comical to them. It was the hollow thunk of American bazooka rounds, bouncing harmlessly off their thick armor plating, ricocheting into the snow like pebbles thrown against a fortress wall. The German tankers would laugh, their voices muffled inside their steel cocoons, mocking the American infantry, who desperately fired their shoulder-mounted weapons at ranges far too great, at angles far too poor, against armor far too thick. These battle-hardened veterans of the Eastern Front had faced Soviet anti-tank rifles, anti-tank guns, and even early rocket launchers, and they had survived. Their Tiger tanks, weighing 60 tons of German engineering excellence, seemed invincible. The Americans, these Germans believed, simply did not possess the technology to threaten their armored behemoths. But warfare has always been a crucible of innovation, and American ingenuity was about to deliver a lesson in lethality that would turn German confidence into terror and transform the laughter of panzer crews into their final sound. The story of how American bazookas evolved from objects of German derision to instruments of armored annihilation is not merely a tale of technological advancement. It is a narrative woven from desperation, scientific brilliance, battlefield adaptation, and the stark realization that in modern warfare, the balance between offensive capability and defensive protection exists in constant flux. To understand the magnitude of this transformation, we must first comprehend the overwhelming challenge that American forces faced when they encountered German heavy armor in the European theater, and why the early bazooka, despite its revolutionary design concept, proved woefully inadequate against the most formidable tanks ever constructed. When American troops first deployed to North Africa in 1942 as part of Operation Torch, they carried with them a weapon that represented a significant leap forward in infantry anti-tank capability. The M1 bazooka, officially designated as the rocket launcher M1, was a revolutionary piece of equipment. Weighing just 13 pounds, this simple tube allowed a single infantryman to fire a rocket-propelled shaped charge warhead capable of defeating armor through the Monroe effect, also known as the shaped charge principle. This principle, discovered by American scientist Charles Edward Monroe in 1888, but not weaponized effectively until World War II, utilized a hollow cone of explosive lined with metal that, upon detonation, would focus the explosive force into a superheated jet of metal plasma, traveling at velocities exceeding 25,000 feet per second. This jet could theoretically penetrate armor not through kinetic energy or brute force, but through the sheer temperature and pressure of the focused explosion, literally burning and punching through steel plate regardless of the projectile's relatively low impact velocity. The concept was brilliant, and in the North African desert, the M1 bazooka proved reasonably effective against German Panzer III and Panzer IV tanks, whose armor thickness ranged from 30 to 80 millimeters depending on the location and model. American soldiers found that if they could maneuver close enough to these tanks, typically within 100 yards or less, and if they could strike the thinner side or rear armor, they stood a reasonable chance of disabling or destroying the vehicle. The psychological impact was equally important. For the first time, ordinary infantrymen possessed a weapon that gave them a fighting chance against armored vehicles, reducing their helplessness in the face of mechanized assault. The bazooka quickly became an icon of American infantry, featured in training films, newsreels, and propaganda. Its name, derived from a musical comedy instrument wielded by radio comedian Bob Burns, became synonymous with American anti-tank warfare. However, the M1 bazooka and its slightly improved successor, the M1A1, suffered from critical limitations that would become catastrophically apparent as American forces advanced into France and eventually into Germany itself. The original M1 fired a 2.36-inch diameter rocket containing approximately 1 pound of pentalite explosive. While the shaped charge design was sound, The relatively small diameter of the warhead meant that the cone of the shaped charge was necessarily limited in size. The depth of armor penetration achieved by a shaped charge is roughly proportional to the diameter of the cone, typically ranging from 5 to 7 times the diameter depending on the explosive composition, cone angle, and standoff distance. With the M1's 2.36-inch warhead, maximum penetration under ideal conditions reached approximately 3 to 4 inches of homogeneous armor plate, roughly 76 to 100 millimeters. This performance proved adequate against medium tanks, but it represented the absolute upper limit of the weapon's capability, achievable only under perfect conditions, with the rocket striking at exactly 90 degrees to the armor surface at the optimal standoff distance. Real battlefield conditions rarely resembled laboratory testing environments. American infantrymen, often poorly trained in the weapon's proper employment due to the rapid expansion of the army and the constant demand for replacements, frequently fired their bazookas at excessive ranges where the slow-flying rocket, traveling at just 265 feet per second, would be easily observed and could be evaded by alert tank crews. They fired at oblique angles where the armor's effective thickness increased dramatically due to the geometry of the impact. They fired in rain, snow, and mud, conditions that could affect the rocket's flight characteristics and the explosive's performance. The battery-powered electrical firing system sometimes failed in cold weather. The rocket motor occasionally misfired or failed to ignite properly. The weapon's effective range was officially listed as 150 yards, but practical accuracy dropped significantly beyond 100 yards, and the slow rocket velocity meant that hitting a moving target at any distance required considerable skill and luck. But these technical limitations, serious as they were, paled in comparison to the challenge posed by an entirely new class of German armored vehicles that began appearing in significant numbers during 1944. The German response to heavy tank losses on the Eastern Front against Soviet armor and anti-tank guns had been to develop tanks with armor thickness that previous generations of weapons simply could not defeat. The Panther tank, introduced in 1943, featured frontal armor 80 millimeters thick on the hull, sloped at 55 degrees from vertical, which gave it an effective thickness of approximately 140 millimeters against projectiles striking from the front. Even more formidable was the TigerTank, which mounted frontal armor 100 millimeters thick on the hull and 120 millimeters on the turret front, arranged in a more vertical orientation that still provided massive protection. And then there was the Tiger II, known to Allied soldiers as the King Tiger or Royal Tiger, which entered production in 1944 and represented the absolute pinnacle of German heavy tank development. This monster mounted 150 millimeters of frontal hull armor and 180 millimeters on the turret front, both heavily sloped for additional protection. The Tiger II's frontal armor, when accounting for the angle of the slope, presented an effective thickness of over 200 millimeters to incoming projectiles. American soldiers who first encountered these heavy tanks experienced a profound shock that rippled through infantry units, created a crisis of confidence. Reports from Normandy in June and July 1944 documented incident after incident of American Bazookas teams engaging German heavy tanks at close range, only to watch in horror as their rockets struck the armor and detonated with a flash and a bang, but failed to penetrate. The shaped charge jet would splash against the thick steel, scarring the surface, sometimes creating a visible divot or crater in the armor plate, but not punching through into the crew compartment or engine bay. The German crews, initially cautious when they spotted American infantry with the distinctive tube-shaped weapons, quickly learned through experience that the bazookas posed little threat to their heavy tanks when fired from the front or even the sides if the range was poor or the angle was wrong. This realization bred contempt and overconfidence. Veteran German panzer crews, many of whom had survived years of brutal combat on the Eastern Front where they had faced Soviet 76.2 mm anti-tank guns, 85 mm tank guns, and masses of T-34 medium tanks found the American bazooka almost quaint by comparison. They understood armor penetration from hard experience. They knew the sound of an anti-tank round that posed genuine danger versus the sound of a weapon that could not harm them. When American bazookas struck their Tigers and Panthers from frontal angles, the German crews would sometimes deliberately expose their tanks, knowing the Americans would waste ammunition in futile attacks. Some crews developed a cruel tactic of waiting for American infantry to fire their bazookas, then immediately advancing on the now revealed position before the loader could prepare another rocket. The psychological advantage shifted dramatically to the Germans. American infantrymen, already facing the terror of confronting 60-ton steel monsters armed with the legendary 88 mm main gun that could destroy American Sherman tanks from distances exceeding a mile, now found that their primary anti-tank weapon had been rendered obsolete by German armor development. The laughter of German tank crews was not merely mockery. It was a manifestation of the supreme confidence that comes from technological superiority. These men knew that short of a direct hit from a large-caliber anti-tank gun, or a lucky shot into the engine deck or rear hull, they were virtually invulnerable to American infantry weapons. They could drive their Tigers and Panthers directly into American defensive positions, weathering bazooka fire that would have destroyed earlier generation tanks, and systematically eliminated American positions with their main guns and machine guns. Reports from the Battle of the Bulge in December 1944 described American infantry companies being overrun by small numbers of German heavy tanks that simply ignored bazooka's fire while methodically destroying foxholes and fighting positions. The psychological impact on American morale was severe. Soldiers who had been trained to believe their bazookas gave them a fighting chance against enemy armor now felt helpless and abandoned. The crisis demanded a solution, and American industry and military planners responded with characteristic urgency and innovation. The problem was clearly understood. The 2.36-inch bazooka's warhead was simply too small to generate a shape-charged jet capable of penetrating 100 to 150 millimeters of armor, particularly when accounting for real-world combat conditions, angles of impact, and the sloped armor designs the Germans had adopted. The solution in principle was straightforward. Increase the diameter of the warhead to create a larger-shaped charge cone capable of deeper penetration. In practice, this solution required redesigning virtually every component of the weapon system. Development of what would become the M20 Super Bazooka, firing a 3.5-inch diameter rocket, began even before the extent of the problem in Europe became fully apparent. American ordnance engineers, studying intelligence reports about German heavy tank development, and observing the effectiveness of the similar caliber German Panzerschreck, which itself was inspired by captured American bazookas, understood that a more powerful weapon would be necessary. The Army Ordnance Department initiated the development program, but the weapon did not reach production in time for widespread deployment during World War II. Only a handful of prototype and early production M20s saw limited action in the final months of the European War, but these engagements would prove revelatory. The M20 represented a quantum leap in portable anti-tank firepower. The launcher itself grew from 5 feet to 6 feet in length, and nearly doubled in weight to approximately 14 pounds unloaded. More importantly, the rocket grew from 2.36 inches to 3.5 inches in diameter, and from 21 inches to 27 inches in length, with the warhead weight increasing from 3.4 pounds to approximately 9 pounds total weight for the complete round. This size increase translated directly into penetration capability. Where the M1 bazooka could penetrate roughly 4 inches or 100 millimeters of armor under ideal conditions, the M20 Super Bazooka could penetrate approximately 11 inches or 280 millimeters of homogeneous armor plate. This performance placed it firmly in the category of weapons capable of defeating even the heaviest German tanks from most engagement angles, provided the shot placement was reasonably good. The first combat encounters between the M20 Super Bazooka and German heavy tanks occurred in isolated incidents during late 1944 and early 1945 as small numbers of the new weapons reached frontline units. The reports that filtered back to Ordnance Command were dramatic. American soldiers who had grown accustomed to the futility of engaging Tigers and Panthers with the old 2.36-inch bazookas were astonished at the destructive power of the new weapon. One particularly detailed after-action report described an engagement near the German border where a Tiger I tank had been systematically destroying American positions, its crew clearly confident in their invulnerability as multiple 2.36-inch bazooka rockets had already bounced off the armor or failed to penetrate. An infantry sergeant equipped with one of the new M20 Super Bazookas worked his way to within 75 yards of the Tiger, which was positioned hull down behind an earthen berm with only its turret visible. The sergeant aimed carefully at the turret's side armor, which at 80 millimeters thick was far thinner than the frontal armor, but still theoretically adequate to defeat the old bazooka. He fired. The rocket streaked toward the target, covering the distance in less than a second. The impact and detonation occurred almost simultaneously. Unlike the previous bazooka hits that had merely scarred the surface, this explosion was followed immediately by a secondary detonation inside the tank. The shaped charge jet had punched completely through the turret side armor and penetrated into the fighting compartment, where it struck stored ammunition. The Tiger's turret hatches blew open as overpressure from the ammunition cook-off sought escape. Flames erupted from every opening. The tank was completely destroyed. The German crew never had time to realize what had happened. Their confidence in their armor protection, built on months of experience with American weapons, bouncing harmlessly off their tank, had made them careless. They had underestimated American technical capability and paid with their lives. This pattern repeated itself in the handful of engagements where American troops equipped with the Super Bazooka encountered German heavy armor in the closing months of the war. The psychological tables turned completely. German tank crews who had grown accustomed to operating with impunity against American infantry suddenly found themselves vulnerable. The problem for the Germans was that the external appearance of the M20 Super Bazooka was not dramatically different from the smaller M1 at combat distances. A German tank commander observing an American soldier with a tube-shaped weapon might reasonably assume it was the familiar 2.36-inch weapon they had learned to ignore, only to discover fatally that this assumption was wrong when the rocket penetrated their armor and killed them. The Germans had no reliable way to distinguish between the two weapons at typical engagement ranges, which meant that every bazooka, regardless of actual type, now had to be treated as a serious threat. This forced German armor to operate more cautiously, to maintain greater standoff distances from American infantry, and to avoid exposing their tanks to close-range infantry attack. The transformation from derision to respect happened not through gradual attrition, but through sudden violent object lessons. When a weapon that has proven ineffective suddenly becomes devastatingly lethal, the psychological impact on the enemy is profound. German training and tactical doctrine had evolved to incorporate the reality of American bazooka ineffectiveness against heavy armor. Tank commanders had learned to accept certain risks that they would never have accepted against Soviet anti-tank weapons. They had developed a casual attitude toward American infantry anti-tank capabilities that bordered on contempt. The Super Bazooka shattered these assumptions in the most brutal way possible. By killing crews who had believed themselves safe, the technical reasons for the Super Bazooka's effectiveness reveal the elegant lethality of properly applied physics. The shaped charge principle depends on creating a lined cone of explosive that, upon detonation, collapses the liner into a high-velocity jet. The deeper the cone, the longer the jet that can be formed, and the deeper the potential penetration. A 3.5-inch diameter warhead allowed for a cone depth approximately 50% greater than the 2.36-inch warhead. This translated into a jet length that was proportionally greater and capable of sustaining its penetrating power over a greater depth of armor. Additionally, The larger warhead could contain more explosive, creating a more powerful detonation that accelerated the liner collapse more effectively. The combination of greater cone depth and more powerful explosive created a synergistic effect that more than doubled the penetration capability compared to the smaller weapon. The standoff distance, meaning the distance between the front of the shaped charge cone and the armor surface at the moment of detonation, also played a critical role. A shaped charge requires a certain distance to allow the jet to fully form before it strikes the armor. Too close, and the jet has not fully developed its penetrating velocity. Too far, and the jet begins to disperse and lose coherence. The M-20's rocket was designed with an optimal standoff distance built into the warhead fuse, ensuring the detonation occurred at the precise moment when the shaped charge jet would achieve maximum effectiveness. This attention to detail in the weapon's engineering made the difference between a rocket that merely damaged armor and one that punched completely through to destroy the tank from the inside. The reality of combat meant that even with the Super Bazooka, engaging German heavy tanks remained extraordinarily dangerous and required considerable skill and courage. The weapon's effective range remained limited to approximately 300 yards maximum, with accuracy dropping significantly beyond 150 yards. The rocket's relatively slow velocity meant that leading moving targets required practice and judgment. The backblast from the rocket motor created a massive signature that immediately revealed the shooter's position, making a second shot from the same location suicidal against alert enemy forces. Loading the weapon required the gunner and assistant gunner to work in coordination, with the assistant removing a rocket from its carrying tube, inserting it into the launcher from the rear, attaching the electrical contact, and signaling ready to the gunner. This process took precious seconds, during which the team was vulnerable. In combat against German armor supported by infantry, bazooka teams often had time for only a single shot before they had to displace or risk being killed by return fire. The tactical employment of the Super Bazooka required careful planning and often substantial courage. The ideal engagement involved ambush tactics, where the bazooka team could position itself in concealment along a route where German armor was expected to pass. The team would allow the tanks to close to point-blank range, often less than 50 yards, before firing. At such close ranges, even hits against the frontal armor of Tigers and Panthers stood a reasonable chance of penetration, and hits against side or rear armor were almost certain to destroy the target. The moment of firing was one of extreme tension. The gunner had to acquire the target, aim at a specific vulnerable point on the tank's armor, and fire in the few seconds available before the tank's turret could traverse to engage the threat. The assistant gunner, crouched behind the launcher, had to brace himself against the backblast while immediately preparing a follow-up round in case the first shot failed to stop the tank. Meanwhile, any German infantry accompanying the armor would be scanning for exactly such threats and would immediately open fire on the revealed position. The courage required to engage a 60-ton TigerTank at close range with a shoulder-fired weapon cannot be overstated. These American soldiers, many of them teenagers or men in their early 20s, who had been civilian farmers, factory workers, or students just months before, had to overcome every natural instinct for self-preservation to position themselves in the path of a massive, armored vehicle specifically designed to kill them. They had to trust that their weapon, which looked and felt remarkably fragile compared to the steel monster bearing down on them, would actually work as advertised. They had to maintain their composure and accuracy while experiencing the visceral terror of having a tank's main gun potentially targeting their exact position. The sound alone of a TigerTank approaching, the grinding of its tracks, the roar of its Maybach engine, the squeal of its steel road wheels created a psychological pressure that many soldiers found overwhelming. Yet despite this terror, American infantry equipped with Super Bazookas achieved remarkable successes when the weapon became available in larger numbers during the Korean War, where it proved its worth conclusively against Soviet-designed T-34-85 tanks used by North Korean and Chinese forces. The lessons learned in the final months of World War II regarding proper tactical employment, the necessity of close-range ambush tactics, and the importance of hitting vulnerable points on enemy armor, all translated effectively to the Korean battlefield. American bazooka teams demonstrated repeatedly that properly employed shape-charge weapons could defeat armor regardless of the size disparity between the man-portable launcher and the target tank. The German experience of having their armor supremacy challenged and ultimately negated by American technological improvement provides important lessons about the nature of military innovation. The Germans had achieved a significant advantage in armor protection through their development of heavy tanks, but this advantage proved temporary because it was fundamentally based on a static assumption that American anti-tank capabilities would remain fixed. The Germans failed to anticipate that American industry, once fully mobilized and focused on a problem, could develop and field solutions with remarkable speed. German intelligence services were aware of American weapons development programs, but German military leadership appears to have underestimated the priority that American commanders would place on countering German heavy armor and the resources that would be dedicated to solving the problem. This underestimation stemmed partially from German contempt for American military capability in general. German military culture, steeped in the Prussian tradition of professional military excellence and hardened by years of brutal combat on the Eastern Front, tended to view American soldiers as poorly trained amateurs who relied on material superiority rather than tactical or technical skill. There was some basis for this assessment. American infantry training was often rushed, and American tactical doctrines sometimes emphasized firepower and material advantage over maneuver and tactical finesse. However, this German assessment failed to account for American strengths in industrial production, technological innovation, and the ability to identify problems and develop effective solutions through systematic analysis and engineering. The story of the bazooka's evolution also illustrates the constant dialectic between armor and anti-armor weapons that has characterized mechanized warfare since tanks first appeared on the battlefield during World War I. Armor development drives anti-armor weapon development, which in turn drives improvements in armor, in an endless cycle of measure and countermeasure. The Germans achieved a temporary advantage by fielding tanks with armor thickness that exceeded the penetration capability of existing American infantry anti-tank weapons, and a temporary advantage with a melodic ride. While the Americans responded by developing a more powerful weapon that restored the balance. Had the war continued, the Germans would presumably have responded with even thicker armor or more sophisticated armor designs, spurring another round of American weapons development. This cycle continues to the present day with modern composite armors, reactive armor, and increasingly sophisticated anti-tank guided missiles. The human dimension of this technological competition deserves emphasis. Behind every technical specification, every metallurgical analysis of armor plate, every calculation of shaped charge jet velocity, stood human beings whose lives depended on the outcome. German tank crews who laughed at American bazookas were not cruel monsters delighting in American suffering. They were young men, many of them teenagers who had been conscripted into military service and sent to fight in a war they did not start. Their laughter was a coping mechanism, a way of managing the constant terror of combat by convincing themselves of their own invulnerability. When that illusion of invulnerability was shattered by an American rocket punching through armor they had trusted to protect them, their laughter turned to screams, and their confidence turned to the horrifying realization that they were about to die, trapped inside a burning steel coffin. Similarly, the American soldiers who fired these weapons were not professional warriors or military enthusiasts. They were citizen soldiers who wanted nothing more than to survive the war and return home to their families and normal lives. They carried bazookas because the army gave them bazookas and told them to use these weapons to destroy enemy tanks. When their weapons proved ineffective, they experienced the helplessness and terror of facing enemy armor they could not defeat. When they finally received weapons capable of penetrating German armor, they experienced relief and renewed confidence, but they still had to summon extraordinary courage to employ these weapons effectively. Every trigger pull represented a moment of supreme danger where survival hung on factors often beyond the soldier's control. The engineering achievement represented by the Super Bazooka should not be minimized. Developing a man-portable weapon capable of defeating the thickest armor then in existence required solving numerous technical challenges. The launcher had to be light enough for one man to carry and aim, yet strong enough to withstand the forces of repeated rocket launches. The rocket had to be compact enough to be portable by infantry, yet large enough to carry a warhead capable of penetrating massive armor. The shaped charge design had to be optimized for maximum penetration through careful attention to cone angle liner material, explosive type, and standoff distance. The electrical firing system had to be reliable under extreme environmental conditions, including mud, water, extreme cold, and extreme heat. The rocket motor had to provide consistent performance across a wide temperature range. Each of these challenges required extensive testing, refinement, and engineering sophistication. American ordnance engineers drew on the nation's deep industrial and scientific capabilities to solve these problems. Universities, private industry, and government laboratories all contributed to the development effort. Metallurgists experimented with different liner materials to optimize jet formation. Chemical engineers developed explosive formulations that provided maximum energy release while remaining stable during transport and handling. Mechanical engineers designed launcher mechanisms that were simple enough for field maintenance, yet reliable enough for combat conditions. This collaborative approach, bringing together expertise from multiple domains and organizations, exemplified the American approach to weapons development and provided a significant advantage over the more centralized and compartmentalized German system. The timing of the Super Bazooka's development and deployment reveals both the strengths and weaknesses of the American military procurement system. The weapon was not ready in time for widespread deployment during World War II, which meant that American infantry faced German heavy armor for most of the European campaign with inadequate anti-tank weapons. This delay cost American lives and allowed German armor to achieve tactical successes that might have been prevented if better weapons had been available earlier. However, the American system proved capable of learning from battlefield feedback, prioritizing development of needed weapons, and eventually fielding solutions, even if those solutions arrived later than ideal. In contrast, German weapons development during the later war years became increasingly divorced from battlefield reality, with resources devoted to exotic wonder weapons that had little practical value, while more mundane but necessary improvements to existing equipment were neglected. The psychological dimension of the Super Bazooka's effectiveness extended beyond its impact on German tank crews. For American infantry, receiving the new weapons represented tangible evidence that their concerns had been heard and addressed, that the Army leadership recognized the problem of inadequate anti-tank weapons and had taken action to solve it. This attention to soldier welfare and combat effectiveness, however imperfect and delayed, helped maintain morale and confidence in leadership. Soldiers who know that their commanders are actively working to give them the tools they need to survive and accomplish their mission will fight with greater determination than soldiers who feel abandoned or forgotten. The Super Bazooka thus served not only as a technical solution to a tactical problem, but also as a psychological boost to infantry morale. The German failure to develop an effective counter to the Super Bazooka before the war's end reflected the deteriorating state of German military technology and industry by 1945. Where earlier in the war, Germany had often led in military innovation, by the war's final year German industry was struggling under constant Allied bombing, shortages of critical raw materials, and the diversion of scientific and engineering talent to impractical projects. German tank armor could not be made significantly thicker without making the tanks so heavy they became immobile or mechanically unreliable. The German response might have been to develop active protection systems, improved tactical doctrine for avoiding infantry anti-tank weapons, or better supporting infantry for their armor. But the chaotic state of German military affairs in 1945 precluded systematic development of such solutions. The Super Bazooka represented more than just a weapon. It embodied a fundamental principle of modern warfare that technological superiority is temporary, and that military effectiveness depends on the ability to adapt, innovate, and respond to enemy developments. The German TigerTank crews, who laughed at American bazookas, were operating under assumptions that had been valid when those assumptions were formed, but had become dangerously obsolete by the time American engineers solved the penetration problem. Their laughter died when the first Super Bazooka rocket penetrated their armor, and with it died the illusion of invulnerability that had allowed them to operate with such confidence. In war, confidence built on outdated information can be as dangerous as outright fear, because it leads to complacency and tactical mistakes that get soldiers killed. The legacy of this David versus Goliath story continues to resonate in modern military affairs. Man-portable anti-tank weapons have proliferated globally and have become increasingly sophisticated, with modern systems like the Javelin and NLOA representing the descendants of the Super Bazooka's concept of giving individual infantry soldiers the ability to destroy armored vehicles. Modern tanks, despite incorporating composite armor, reactive armor, and active protection systems, remain vulnerable to infantry anti-tank weapons when those weapons are properly employed. The fundamental equation, established during World War II, remains valid today. Armor provides protection but not invulnerability, and infantry anti-tank weapons, properly designed and employed, can defeat even the most heavily armored vehicles. The challenge for armor designers is to make their vehicles survivable enough to accomplish their mission despite the threat, while the challenge for anti-armor weapon designers is to defeat protective measures through improved penetration, better targeting, or tactics that exploit armor vulnerabilities. The story of German soldiers laughing at American bazookas until that laughter turned to final screams inside burning tanks serves as a powerful reminder of war's brutal unpredictability and the dangers of assumptions. Those German crews were not laughing from cruelty, but from relief, from the belief that they possessed a decisive advantage that would protect them. American industry and ingenuity took that advantage away, not through gradual erosion, but through sudden, violent negation. The first German crew to face a Super Bazooka had no warning, no time to adjust their tactics, no opportunity to request better armor or different equipment. They simply died, victims of a technological surprise that turned their strength into a death trap. Their experience became a warning to other German crews, but by the time that warning could spread and influence tactics, the war was already entering its final phase and German armor was increasingly unable to operate effectively regardless of the anti-tank threat. For the American soldiers who wielded these weapons, the Super Bazooka represented both liberation from helplessness and a terrible responsibility. They now possessed the power to destroy the tanks that had terrorized them. But exercising that power required closing to ranges where they themselves were extraordinarily vulnerable. The weapon gave them capability, but not safety. It gave them a fighting chance, but not a guarantee. And it required them to overcome their very reasonable fear of massive armored vehicles, to employ the weapon at the close ranges where it was most effective. These soldiers, carrying their ungainly tubes and their canvas bags of rockets, represented the culmination of American industrial might and scientific innovation translated into infantry portable form. When they pressed their firing triggers and sent their rockets streaking toward German steel, they were not just firing a weapon, but unleashing the accumulated efforts of thousands of engineers, scientists, factory workers, and logistics personnel who had collectively created the tool that would penetrate the seemingly impenetrable. The moment when a Super Bazooka rocket punched through TigerTank armor and detonated inside the crew compartment, represented a microcosm of the broader trajectory of World War II. American material and technological superiority, slow to develop and often wasteful in its application, eventually overwhelmed German tactical excellence and engineering sophistication. Through sheer volume and systematic problem-solving, the Germans could build better tanks individually, but they could not build enough of them, could not provide them with adequate fuel, could not replace lost crews fast enough, and ultimately could not develop counters to American solutions quickly enough to maintain their advantages. The Super Bazooka was one small part of this larger pattern, but it was a telling example, because it showed that American innovation could match and exceed German technology when properly motivated and resourced. The sound of German laughter dying in the confines of a TigerTank, replaced by screams and then silence as ammunition cooked off and flames consumed everything inside the steel hull, marked the end of one era and the beginning of another. It marked the end of the era when German heavy armor could operate with relative impunity against American infantry, and the beginning of an era when every German tank crew had to treat every American soldier with a tube-shaped weapon as a potentially lethal threat. This shift in the psychological balance of the battlefield, multiplied across thousands of engagements and hundreds of thousands of soldiers, contributed to the eventual collapse of German military resistance. When soldiers lose confidence in the equipment that is supposed to protect them, when the tools they rely on prove inadequate against enemy weapons, morale deteriorates and combat effectiveness declines. German tank crews in the war's final months faced not only superior numbers of Allied armor, but also an increasingly effective anti-tank threat from infantry weapons they had once dismissed as harmless. This combination of external pressure and internal doubt accelerated the disintegration of German defensive capabilities. The American soldiers who fired the Super Bazooka did not think in these grand strategic terms. They thought about survival, about protecting their fellow soldiers, about completing their mission and going home. When they saw their rocket penetrate a Tiger tank that had previously seemed invulnerable, they felt satisfaction and relief. They had struck back against an enemy that had terrorized them. They had proven that American weapons could match German steel. They had avenged friends killed by German tanks in earlier engagements, when their old bazookas had proven useless. These personal immediate reactions mattered more to them than any abstract notions of technological progress or strategic advantage. War at the infantry level is intensely personal and immediate, measured in yards rather than miles, in minutes rather than statistics. Yet from these individual moments of violence and technological application emerged patterns and outcomes that shaped the war's conclusion. German armor losses mounted, German tactical confidence eroded, American infantry gained experience and capability. The balance shifted incrementally through thousands of small encounters where American weapons proved adequate to the task while German advantages diminished. The Super Bazooka was never a war-winning weapon in itself. It could not defeat Germany single-handedly, but it was one tool among many that collectively gave American forces the capability to match and eventually overcome German military power. In war, victory rarely comes from a single decisive weapon or battle, but rather from the accumulation of small advantages that collectively create an insurmountable superiority. The German soldiers who died when Super Bazooka rockets penetrated their tanks deserve remembrance not as faceless enemies, but as human beings caught in circumstances beyond their control. They did not choose to laugh at American weapons out of inherent cruelty, but out of self-defense mechanisms that helped them cope with constant danger. They did not choose to crew Tiger tanks out of love for war, but because they were ordered to do so by a regime they may or may not have supported. When they died, they left behind families, friends, and unfulfilled lives, just as their American adversaries would have if the situations were reversed. War's tragedy lies not just in the suffering it causes, but in the way it transforms human beings into targets and weapons, into instruments of mutual destruction. The technological competition between armor and anti-armor weapons for all its engineering sophistication, ultimately comes down to human beings trying to kill other human beings more effectively than they can be killed in return. The laughter that died inside German Tiger tanks when American rockets finally pierced their armor was the laughter of young men who wanted to believe they were safe, who needed to believe their equipment would protect them, who used mockery and contempt as shields against their own fear. When those psychological shields failed simultaneously with their physical armor, they experienced the full horror of their vulnerability in the final seconds or minutes before death claimed them. This is war stripped of glory and romance, reduced to its essential brutality. Technology enables this brutality and makes it more efficient, but it does not change the fundamental reality that war means human beings dying violently, often in pain and terror, far from home and everyone they love. The American development of the Super Bazooka represents human ingenuity applied to the problem of killing more effectively, which is both impressive as an engineering achievement and disturbing as a reflection of human civilization's priorities. The same scientific principles, industrial capabilities, and organizational skills that went into creating a weapon capable of penetrating 12 inches of armor could have been applied to peaceful purposes, to building rather than destroying, to preserving life rather than ending it. But war creates its own logic and its own demands, and nations at war must either develop effective weapons or accept defeat and occupation. The moral complexity of weapons development lies in this terrible necessity, in the fact that choosing not to develop better weapons often means condemning one's own soldiers to death at the hands of better armed enemies. Yet developing those weapons means perpetuating and escalating the cycle of violence. The engineers who designed the Super Bazooka faced this moral complexity, whether they acknowledged it or not. Their work would save American lives by giving American infantry an effective tool against German armor. Simultaneously, their work would end German lives by enabling American soldiers to destroy tanks and kill the men inside them. The engineers likely focused on the former consideration, on the lives they would save, on the contribution they were making to defeating Nazi Germany and ending the war. This framing allowed them to proceed with their work, without being paralyzed by contemplation of the death and destruction their creation would cause. It is the same psychological mechanism that allows soldiers to kill in combat, the ability to focus on mission accomplishment and friendly force protection rather than on the humanity of the enemy. The battlefield application of the Super Bazooka revealed truths about infantry combat that transcend any specific weapon system. Infantry warfare at close quarters remains intensely personal and terrifying regardless of technological advancement. The American soldier crouching in a foxhole or behind rubble, watching a TigerTank approach while gripping his Super Bazooka, experienced fear that differed in degree, but not in kind, from the fear experienced by soldiers throughout human history facing superior enemy forces. The technology had changed dramatically from the spears and swords of ancient warfare, but the fundamental human experience of combat, the terror and the courage required to face that terror, remained constant. The Super Bazooka gave the American soldier greater capability, but it did not eliminate his fear or reduce the courage required to employ the weapon effectively. The training required to use the Super Bazooka effectively illustrated the challenges of rapidly expanding a military force during wartime. American training programs had to take civilians with no military experience and transform them into competent soldiers capable of complex technical and tactical tasks, all within a time frame measured in months or even weeks. Teaching a soldier to fire a bazooka accurately required instruction in the weapon's mechanical operation, in range estimation, in leading moving targets, in selecting proper aim points on different types of enemy vehicles, in working effectively with an assistant gunner, in tactical employment principles, and in maintaining composure under the stress of combat. Some soldiers mastered these skills quickly and became highly effective bazooka gunners. Others struggled with the technical aspects or could not overcome their fear sufficiently to operate effectively in combat. The quality of training varied considerably depending on where and when a soldier went through the training pipeline, with soldiers trained early in the war often receiving more thorough instruction than replacements rushed through training to fill casualties in combat units. The logistics of supplying Super Bazooka ammunition to frontline units presented challenges that affected the weapon's combat effectiveness. Each rocket weighed approximately 9 pounds and was packaged in a protective cardboard tube. A soldier could reasonably carry 3 or 4 rockets, in addition to his other equipment, but this represented a significant weight burden. Infantry companies equipped with bazookas needed dedicated ammunition carriers to ensure adequate supply of rockets, and this requirement competed with other demands for manpower including riflemen, machine gunners, medics, and radio operators. Resupplying bazooka teams during combat was difficult and dangerous, requiring either the teams to fall back to resupply points or for ammunition to be brought forward under fire. A bazooka team that exhausted its ammunition became combat ineffective, regardless of the gunner's skill or courage, and the weight and bulk of the rockets limited how much ammunition could be positioned forward with the teams. The development timeline of the Super Bazooka, with its introduction coming too late for widespread use in World War II, but in time for extensive employment in Korea, raises questions about military procurement processes and the ability of military organizations to respond to evolving threats. The ineffectiveness of the 2.36-inch bazooka against German heavy armor became apparent to frontline soldiers by mid to late 1944, yet the institutional response, while it ultimately produced an effective solution, could not deliver that solution to troops in large numbers before the European War ended in May 1945. This lag between problem identification and solution implementation reflected the inherent difficulties of weapons development, testing, production, and distribution, but it also reflected organizational and bureaucratic factors that slowed the process. Military organizations, like all large bureaucracies, respond slowly to new information and struggle to prioritize among competing demands for limited resources. The Korean War provided the proving ground where the Super Bazooka demonstrated its full potential against enemy armor in sustained combat. North Korean T-34-85 tanks, with armor thickness comparable to German Panther tanks, proved vulnerable to the 3.5-inch rockets when American infantry employed proper ambush tactics early in the Korean War. Before adequate numbers of Super Bazookas reached frontline units, American infantry experienced similar helplessness against T-34 tanks as they had felt against German Tigers and Panthers. The old 2.36-inch bazookas proved largely ineffective against the Soviet-designed tanks, and North Korean armor achieved significant tactical successes by exploiting this advantage. The arrival of Super Bazookas in quantity during late 1950 shifted the balance dramatically. American infantry, having learned hard lessons about bazooka employment against heavy armor in World War II, applied those lessons effectively in Korea. North Korean tank crews discovered that American infantry positions were far more dangerous than they appeared, and T-34 losses to bazooka fire mounted steadily. The Korean experience validated the tactical doctrine that had emerged from late World War II encounters between Super Bazookas and German armor. Effective employment required close-range ambushes, disciplined fire control to avoid revealing positions prematurely, careful selection of aim points to strike vulnerable areas of enemy tanks, and rapid displacement after firing to avoid return fire. American infantry in Korea became increasingly skilled at these tactics, transforming the bazooka from a weapon of desperation into a highly effective anti-armor system. When employed by trained and experienced soldiers, the confidence that came from knowing their weapons could defeat enemy armor transformed American infantry from potential victims of armored assault into tank hunters capable of destroying enemy vehicles through superior tactics and determination. The comparison between the American approach to the anti-tank problem and the approaches taken by other nations reveals different military cultures and industrial capabilities. The British, facing similar challenges with German heavy armor, developed the PA-8, an entirely different type of infantry anti-tank weapon that used a spring-powered spigot mortar rather than a rocket. The PA-8 was heavy, difficult to cock, and had very short range, but it used a large hollow charge warhead that could defeat thick armor and produced no backblast signature. The Soviet approach emphasized conventional anti-tank guns and high-velocity tank guns rather than infantry portable rockets. Although they did develop the RPG series of weapons, the German Panzerfaust and Panzerschreck represented their own solutions to the infantry anti-tank problem. With the Panzerschreck being directly inspired by captured American bazookas, each nation's approach reflected its industrial capabilities, tactical doctrine, and the specific threats its forces. The American solution, emphasizing a man-portable rocket launcher with increasing rocket calibers, proved effective and influential, setting the pattern for subsequent anti-tank weapon development worldwide. The evolution of the bazooka from an object of German derision to a weapon capable of destroying the heaviest German tanks represents a case study in military adaptation and innovation under pressure. The process involved multiple steps and required contributions from multiple communities. Frontline soldiers had to recognize the problem and report it through channels. Intelligence services had to assess the German armor threat accurately. Ordnance engineers had to understand the technical requirements for defeating thicker armor. Industrial facilities had to manufacture the new weapons and ammunition. Logistics systems had to deliver the weapons to frontline units. Training establishments had to teach soldiers how to employ the new weapons effectively. Each of these steps involved challenges and potential failure points. The fact that the process ultimately succeeded, even if not as quickly as might have been desired, demonstrated organizational capacity for self-correction and adaptation. The human cost of the delayed deployment of adequate anti-tank weapons can never be fully calculated. American soldiers who died in combat against German heavy armor when their 2.36-inch bazookas proved ineffective might have survived if they had been equipped with Super Bazookas from the beginning. Units that were overrun by German armor that they could not defeat might have held their positions if they had possessed adequate anti-tank weapons. The lives lost during this gap between problem identification and solution implementation represent one of war's many tragedies. The fact that institutional processes move slowly while soldiers die quickly. Yet the counterfactual is equally stark. Without any portable anti-tank weapons, American infantry would have been even more helpless against German armor, and losses would likely have been higher still. The 2.36-inch bazooka, for all its limitations against heavy armor, still provided some capability against lighter vehicles, and could occasionally achieve lucky hits on heavy tanks that disabled them. The psychological impact on German tank crews of encountering an effective American anti-tank weapon after months of relative impunity against bazookas deserves closer examination. German veterans of the Eastern Front had learned to respect Soviet anti-tank capabilities through brutal experience. Soviet anti-tank guns, tank destroyers, and infantry anti-tank weapons had destroyed thousands of German tanks and killed thousands of German tankers. German crews operating on the Eastern Front maintained constant vigilance and employed careful tactics to minimize exposure to anti-tank weapons. When these same crews or their comrades deployed to the Western Front and encountered the ineffective 2.36-inch American bazookas, they experienced a dramatic reduction in the anti-tank threat level. This allowed them to operate more aggressively and with less caution than they would have employed against Soviet forces. The appearance of the Super Bazooka disrupted this learned behavior pattern and forced German crews to reassess the threat environment. However, the relatively small numbers of Super Bazookas deployed before the war's end meant that many German crews never encountered the weapon and therefore maintained their overconfidence regarding American anti-tank capabilities until either the war ended or they were destroyed by other means. The crews that did encounter Super Bazookas and survive the experience undoubtedly spread warnings to other crews, but the chaotic state of German military communications in the war's final months meant that such tactical intelligence often failed to reach all units that might have benefited from it. Some German crews likely died never knowing that American infantry anti-tank capabilities had improved dramatically, still operating under the obsolete assumption that bazookas posed minimal threat to their Tigers and Panthers. The technical sophistication required to manufacture Super Bazooka rockets illustrated American industrial capability at its peak. Each rocket required precision metalworking to create the shaped charge cone liner, careful explosive loading to ensure consistent performance, manufacturing of the rocket motor with its propellant grain shape to provide optimal thrust characteristics, assembly of the electrical firing system, and quality control testing to ensure reliability. This had to be accomplished at industrial scale, producing thousands of rockets per day, with consistent quality across different manufacturing facilities and production runs. American industry proved capable of meeting these demands, ramping up production of a completely new munition type, while simultaneously maintaining production of hundreds of other weapons systems and millions of tons of other military equipment. This industrial capacity, as much as any tactical or technological factor, ultimately determined the war's outcome. The individual stories of American soldiers who successfully employed super bazookas against German armor deserve preservation and remembrance. Each engagement represented a moment of supreme courage, where an individual soldier faced a massive enemy war machine and prevailed through skill, determination, and the effectiveness of his weapon. These were not faceless statistics, but human beings with names, families, hopes, and fears who rose to an extraordinary challenge and succeeded. Some of these soldiers survived the war and returned home to live normal lives, carrying memories of the day they destroyed a TigerTank that would have killed them and their comrades. Others died in subsequent combat or from other causes, their brief moment of triumph over German armor just one incident in short lives cut tragically short by war. Still others were wounded in the engagement or shortly thereafter, carrying physical and psychological scars for the remainder of their lives. The German crews who died when Super Bazooka rockets penetrated their armor also deserve remembrance as individuals rather than as representatives of a defeated enemy. These men had families who mourned their loss, friends who remembered them, and lives that were ended before they could fully develop. Some were convinced Nazis who believed in the regime they served and died, thinking their cause was just. Others were conscripts who had no ideological commitment to Nazism, but fought because they had no choice and believed they were defending their homeland. Still others were teenagers pressed into service in the desperate final months of the war, given minimal training, and sent into combat in powerful weapons they barely knew how to operate. Their laughter at American bazookas was a brief moment of relief in lives dominated by fear and hardship, and their deaths inside burning tanks was a terrible end that no human being should have to experience regardless of the uniform they wore or the cause they served. The technical lessons learned from the bazooka's evolution influenced post-war weapons development worldwide. The principle that infantry portable weapons could defeat heavy armor through shaped charge technology became fundamental to modern military doctrine. Every modern army equips its infantry with anti-tank weapons descended conceptually from the bazooka, whether rocket-propelled grenades, recoilless rifles, or guided missiles. The basic insight that a properly designed shaped charge can defeat armor far thicker than traditional anti-tank rifles or kinetic penetrators could manage remains valid. Modern anti-tank weapons have become dramatically more sophisticated, with tandem warheads to defeat reactive armor, top attack trajectories to strike thin roof armor, and guidance systems for improved accuracy. But they all trace their lineage back to the simple tube and rocket concept pioneered by the bazooka. The countermeasures developed to defeat shaped charge weapons have evolved in parallel with the weapons themselves. Modern tanks incorporate composite armor designed to disrupt shaped charge jets, explosive reactive armor that detonates outward to destroy incoming warheads, active protection systems that detect and intercept anti-tank rockets before they strike the day, vehicle and soft kill systems that interfere with guidance systems of anti-tank missiles. This technological competition between armor and anti-armor continues unabated, with each new defensive measure spurring development of new offensive capabilities in an endless cycle. The fundamental equation remains unchanged from World War II. Armor provides protection but can always be defeated by sufficiently powerful weapons, while anti-armor weapons provide capability but cannot eliminate the tactical advantages that armored vehicles provide in terms of mobility, protection, and firepower. The role of individual initiative and innovation in the bazooka's development and employment deserves recognition. While the Super Bazooka emerged from institutional weapons development programs involving thousands of people, its effective combat employment often depended on individual soldiers developing tactics through trial and error under combat conditions. Sergeants and junior officers who recognized that bazookas needed to be employed at close range in ambush positions, who learned which parts of enemy tanks were most vulnerable, who developed techniques for coordinating bazooka teams with other infantry weapons, contributed as much to the weapon's effectiveness as the engineers who designed it. These tactical innovations emerged from combat experience and were shared informally between units through the networks of personal relationships that connected soldiers. Official doctrine manuals codified these lessons eventually, but the frontline innovators, who discovered effective tactics through dangerous experimentation, deserve credit for transforming a weapon with theoretical potential into a practical combat tool. The Super Bazooka's effectiveness against German armor represented more than just a technical achievement. It represented a validation of the American way of war, emphasizing industrial production, technological innovation, and systematic problem-solving over individual tactical brilliance or warrior tradition. The Germans excelled at tactical innovation, operational art, and individual soldier training. Their military tradition emphasized initiative, aggressive action, and sophisticated combined arms operations. Yet these advantages proved insufficient against American material superiority once American technological capabilities were brought to bear on military problems. The Super Bazooka was one small example of this larger pattern, but it illustrated the principle clearly. When American engineers identified a problem, developed a solution, and American industry manufactured that solution in quantity, German tactical excellence could not overcome the material disadvantage. This is not to suggest that material superiority alone determined the war's outcome, or that American soldiers lacked courage and skill. American infantry who carried bazookas into combat against German armor demonstrated extraordinary bravery and developed considerable tactical proficiency. The point is rather that American military effectiveness derived from the combination of adequate individual soldier quality with superior material and technological resources. An American soldier with a Super Bazooka was more effective than a German tank crew in a Tiger when the engagement occurred at close range under conditions that favored the infantryman. But it took American industrial might to arm enough soldiers with effective weapons to shift the overall balance, and it took American technological capability to develop weapons that could match German armor. The lasting image of the Super Bazooka punching through TigerTank armor encapsulates multiple layers of meaning. At the most basic level, it represents the triumph of engineering and physics over metallurgy and mass. The shaped charge principle, properly applied in a warhead of adequate size, could defeat armor of any practical thickness. At another level, it represents the democratization of anti-tank capability, giving individual infantry soldiers the power to destroy armored vehicles that had previously required dedicated anti-tank guns or other armored vehicles to defeat. This shifted tactical possibilities and gave infantry greater battlefield agency. At yet another level, it represents the reversal of psychological dominance from German to American forces, as the weapon that had been mocked became genuinely feared. And at the deepest level, it represents the terrible ingenuity that humans bring to the task of killing one another, the way that scientific knowledge and industrial capability are marshaled to make warfare more deadly and effective. The laughter of German soldiers encountering ineffective American bazookas in 1944 turned to screams inside burning tanks when effective bazookas appeared in 1945, completing a cycle of technological obsolescence, adaptation, and reversal that has repeated throughout military history. The specific weapons change, the specific armies change, but the fundamental pattern endures. Advantage leads to overconfidence. Overconfidence leads to complacency. Complacency creates vulnerability, and vulnerability leads to defeat. The German crews who laughed were not foolish to do so, given the information available to them. Their bazookas had proven ineffective repeatedly, and their armor had protected them reliably. They made a reasonable extrapolation from past experience to future expectations. Their error was in assuming that the current situation would persist indefinitely, that American capabilities would remain static while German advantages remained intact. This error cost them their lives when American engineers changed the equation. For the American soldiers who finally possessed weapons capable of defeating German heavy armor, the Super Bazooka represented vindication and empowerment. They had endured months of helplessness, watching their inadequate weapons fail against enemy tanks, feeling abandoned and under-equipped. The arrival of weapons that actually worked, that actually penetrated the armor and destroyed the tanks, transformed their experience of combat. They were no longer helpless victims but capable hunters. This psychological transformation mattered as much as the technical capability. Soldiers who believe they have the tools to accomplish their mission fight with greater determination and effectiveness than soldiers who feel their equipment is inadequate. The Super Bazooka gave American infantry that confidence, that belief in their own capability, which translated into improved combat performance across countless engagements. The story culminates in that single moment when a shaped charge jet, traveling faster than the speed of sound punches through steel plate that had seemed impenetrable, when the confident laughter inside a German tank is cut short by the catastrophic failure of the armor, when American ingenuity and German arrogance meet in violent resolution. In that instant, lasting microseconds, the jet bores through armor. The explosive energy dissipates into the crew compartment. Fragments of steel and copper spray in all directions, and human bodies are torn apart by forces they never saw and barely had time to hear. The tank, which moments before had been a functioning war machine with a living crew, becomes a tomb. The American soldier who fired the rocket, crouched 75 yards away, watches the tank explode and knows his shot was successful. He feels satisfaction, relief, and perhaps the beginning of regret that will grow over the years as the immediate necessity of survival gives way to reflection on what he did and what it meant. This is the reality of war that exists beneath the statistics and the strategic analysis and the technological specifications. This is where human beings kill other human beings with weapons designed for maximum effectiveness, where laughter turns to screams, where confidence becomes terror, where life ends suddenly and violently. The Super Bazooka was an effective weapon because it killed effectively. That effectiveness came at the cost of German lives, lives that ended in pain and fear inside burning metal coffins. This is not to suggest moral equivalence between those fighting for democracy against fascism, but rather to acknowledge the human cost on all sides. The terrible waste of young lives that war demands regardless of the justness of the cause. The technological achievement represented by the Super Bazooka deserves recognition and study. The courage of the American soldiers who employed it against terrifying odds deserves honor and remembrance. The tactical and strategic implications of infantry portable anti-tank weapons continue to shape modern warfare. But we must also remember the human beings who died when those rockets found their mark, who laughed at weapons they thought could not harm them, who learned too late that their assumptions were wrong, who spent their final moments in agony and terror. This complete picture, encompassing technological triumph and human tragedy, provides the only honest accounting of what happened when American bazookas finally penetrated German Tiger tanks like butter, ending laughter with fire and steel.